Welcome back to second lecture on Class 10 Science Chapter 4 Carbon and its Compounds. In the first lecture, we studied about covalent bonding. We studied that carbon forms a large number of compounds. The total number of carbon compounds are in millions. So how is carbon able to form such a large number of compounds? This is because of the versatile nature of carbon. So this will be a topic for this lecture. So, two major properties are responsible for the versatile nature of carbon. These properties are catenation and tetravalency. Now let's study about each one of them in detail. First, catenation. So carbon has a very unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This ability is known as catenation. So basically, catenation is the unique ability of carbon. It is a unique self-linking ability of carbon in which the carbon can form bonds with other atoms of carbon. Now, carbon can form different types of chains. It can form straight chain, branch chain, or cyclic chain. In straight chain, the carbon atoms are arranged in a single straight line, as you can see in this example. So, at most, each carbon atom is bonded with two other carbon atoms. Second, branched chain. In this, the carbon atoms are arranged in a branched fashion, as you can see in this example. Now, in this, one or more carbon atoms has at least 3 bonds. So, in this example, you can see that the second and third carbon atoms are having 3 bonds each. Third, ring or cyclic chain. In this in ring or cyclic chain, the carbon atoms are arranged in a ring-like structure. Second, tetravalency. Carbon has valency of 4. So it is able to form bonds with 4 other atoms of carbon or other elements. Carbon bonds with oxygen, hydrogen, nitrogen, sulfur, chlorine, etc., giving rise to large number of compounds with different properties. So due to both these properties, that are catenation and tetravalency, carbon has such a large number of compounds. Now let's discuss about a very special category of carbon compounds, that are hydrocarbons. So the carbon compounds which contain only carbon and hydrogen are called hydrocarbons. Hydrocarbons are further classified into 2 categories: saturated and unsaturated. Saturated hydrocarbons have single bonds between the carbon atoms, while unsaturated hydrocarbons have double or triple bonds between the carbon atoms. The saturated hydrocarbons are known as alkanes. So alkanes are the other name for saturated hydrocarbons, while unsaturated hydrocarbons are further classified into alkenes and alkynes. Alkenes have one or more double bonds between the carbon atoms, and alkynes have one or more triple bonds between the carbon atoms. So single bond alkenes, double bond alkenes, and triple bond alkynes. Now let's discuss the naming of hydrocarbons. First, let's discuss the naming of alkenes. So, while naming the hydrocarbons, we have certain prefixes. So, if one carbon atom is present in the entire hydrocarbon, then the prefix meth is used. If 2 carbon atoms are present in the hydrocarbon, then eth is used. If 3 are there, then prop. If 4 are there, then bute. If 5 are there, then bent. And if 6 carbon atoms are there, then hex prefix is used. So let's see how we will name different alkanes by using these prefixes. So if there is 1 carbon atom, then the name of the alkane will be methane. If there are 2 carbon atoms, then it will be ethane. Similarly, for 3 it will be propane, for 4 it will be butane, for 5 it will be pentane, and for 6 it will be hexane. So basically, whenever we have to name the alkanes, then we use the prefixes according to the carbon atoms, number of carbon atoms, and we use the suffix, that is ane. So for alkanes, the suffix ane is used. Similarly, we can do the naming for alkenes and alkynes. For alkenes, the suffix ene is used, and for alkynes, the suffix yne is used. So just we have to keep the prefixes as same according to the number of carbon atoms, and we have to change the suffix according to what we are asked. If we are asked alkanes, then ane is used. If alkenes are asked, then ene is used. And if alkynes are asked, then yne is used. Now let's solve few practical questions and understand the naming of hydrocarbons and draw the structure of hydrocarbons. Now let's study how we draw the structure of hydrocarbons. For this, we shall take various examples. First, let's take the example of an alkane. So let's take the example of propane. Now let's see what we can infer from the name. So the meaning of this prefix prop means that it is a 3-carbon compound. This is because, as I told you in the previous sections, that the meaning of prop is 3 carbon. The number of carbon atoms in the compound are 3. So we shall draw 3 carbon atoms in a straight line. Now let's see what is the meaning of the suffix ane. So the meaning of the suffix ane means that it is an alkane, and always alkenes have single bonds. So this means that the bonding between all the carbon atoms would be single bond. So we shall draw single bonds between all the carbon atoms. This single line means that there is single bond between the carbon atoms. Now we will place hydrogen atoms in all the places that are vacant. So for this first carbon, we know that it has a valency of 4. So it has 4 valence electrons in its outermost shell. Now 1 electron has already been shared with this second carbon. So this means that 3 electrons are left with this first carbon. So basically we will draw 3 hydrogen atoms. It will bond with 3 hydrogen atoms. So now this carbon atom has shared all its 4 valence electrons, and in this way it has become stable. Now let's take the example of second carbon atom. So 2 of its electrons have already been shared and 2 are left. So it will bond with 2 other hydrogen atoms. Now its all the valence electrons have also been shared. Now this third carbon atom, it will also bond with 3 other hydrogen atoms, because 1 electron has already been shared and 3 places are left. So the thumb rule for drawing the structure of hydrocarbons is that first you draw, the step 1 is to draw the carbon atoms, and then whatever electrons are left, whatever valence electrons are not shared, in those places we will replace them by hydrogen atoms. Now let's take the example of an alkene, that is ethene. So let's see what we can infer from its name. So we can see that the meaning of the prefix eth means that it is a 2-carbon compound. So the number of carbon atoms present in the compound are 2. Now the meaning of the suffix ene means that it is an alkene, and this means that it has 1 or more double bond between the carbon atoms. So basically it is 2-carbon compound, so it will have 2 carbons, and it has 1 or more double bonds between the atoms. So as there are only 2 carbon atoms here, so obviously they will have a double bond between them. Now let's see how many valence electrons are left with these carbon atoms. So for this first carbon atom, you can see that 2 of its electrons are shared, and as it has valency of 4, so 2 electrons are left. So basically we will put 2 hydrogen atoms in place of those. And similarly for the second carbon atom, again we will put 2 hydrogens, because again 2 electrons are left to be shared. So now this entire compound is stable, and so you can see that this is the structure for ethene. So now we can write it in a formula way as C2H4, because the number of carbon atoms are 2 and the number of hydrogen atoms are 4. So the chemical formula of ethene would be C2H4. Now let's take another example. This time we are having the example of an alkane, that is butane. So as the word but is mentioned, but means that it is a 4 carbon compound. So 4 carbon atoms are present. So let's make the structure. Now as the suffix ane is present, so this means that there are single bonds between the carbon atoms. So here we have drawn single bonds between all the carbon atoms. Now we will replace all the valence electrons which have not been shared yet with hydrogen atoms. So for this first carbon, 1 electron has been shared, 3 are left, so we will put 3 hydrogen. It will bond with 3 hydrogen. The second, 2 are shared, so it will bond with 2 hydrogen. For this third again, it will bond with 2 hydrogen. And now for this fourth carbon, again only 1 electron has been shared, so it will bond with 3 other hydrogen to complete its octet. So this is the structure of butane. Now one very important thing to note is that, is this the only possible structure for butane? Is this the only possible structure that can be made for representing butane? No. So for representing the carbon compounds, for drawing the structure of hydrocarbons, we can draw more than one structures. So hydrocarbons can have more than one structure. Now I am sharing a second structure which can be drawn to make butane. So for the second structure, if we put 3 carbons like this, and instead of putting the 4th carbon in the straight chain, if we put it in a branched chain, then this will be the structure. Here again it is having 4 carbon atoms, so it is but. Now we will replace the rest of the valence electrons with hydrogen. So for this first carbon, 3 valence electrons are left, so we will put 3 hydrogen. For the second, now for the second, this middle carbon, 3 electrons have already been shared, so only 1 hydrogen can be put. Now for this third, again 3 hydrogen will be put, and for this fourth, this down one, again 3 hydrogen will be put, as only 1 electron has been shared. So with this, we have got 2 possible structures of butane. Now to check them, if both of them are butane, what we will do is we will calculate the formula. Now for this first structure, if you see that there are 4 carbon, so it is C4, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 hydrogen. So the chemical formula of butane becomes C4H10. And for the second structure again, there are 4 carbon, so C4, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen, so H10. So basically for both of these structures, we are getting the same chemical formula, that is C4H10. This means that both of them are the same. So thus, with this example, we have learned that hydrocarbons can have more than one structure, and such compounds with identical molecular formula but different structure are called isomers. So till now, we have drawn the structure of hydrocarbons in branched or straight chain fashion. Now let's see how we will draw the structure of cyclic chains or rings. So let's take an example. We will take the example of cyclohexane. So let's split and understand what is the meaning of this word. So the meaning of cyclo means that it is a cyclic chain. So this means that we have to arrange the carbon atoms in cyclic chain form, in ring form. The meaning of hex is that 6 carbon atoms are present. 6 carbon atoms are present. And the meaning of ane is that it is an alkane, so there is single bonding between the carbon atoms. Single bonding. So we have got that we have to make a cyclic chain of 6 carbons and there is single bonding between all of them. So let's draw a structure. Here I am taking 6 carbons and there is single bonding between all of them. We have made them in a ring form. So to show that it is in a ring, you must ensure that the first and last carbon must meet with each other. So it must be a closed chain. You can even draw it in a rectangular fashion. So you can draw it like this also. This will also be correct, but this is better, so we are drawing it like this. Now again what we will do is that we will see what are valence electrons are left and we will put hydrogen atoms in place of them. So let's start with this carbon atom. Now for this carbon atom, 2 of its electrons have been shared, so 2 electrons are left, so it will bond with 2 hydrogen atoms. Similarly, this again 2 will be left, 2 hydrogen atoms will be present. Now for all these carbon atoms, you can see that 2 electrons have been shared and 2 are left. So for all the carbon atoms, we will place 2 hydrogen. So with this we have got the structure of cyclohexane, which is C6 and HR12. So cyclohexane formula is C6H12. This was all about this lecture. In next lecture we shall discuss more about carbon compounds. Thank you.